Okay, so let's pick this reaction apart. The first thing we need to do is we need to write a word and balanced equation. So the thermal decomposition of copper carbonate is copper carbonate, and we heat it and we break it down with heat, thermal decomposition, to copper oxide and carbon dioxide. So copper carbonate was that green solid we started off with. We ended up with a black solid of copper oxide and carbon dioxide gas. I'll just squeeze that on there. So let's try and write a balanced equation now. So the formula for copper carbonate, so copper is Cu, and remember Cu has a 2+ charge. I'll just write them in for now. We don't have to write them in if you understand how this works. A carbonate ion is CO3, and that also has a 2- charge. The whole thing has a 2- charge. So they're balanced, so we don't have to duplicate any of these in order to balance the charges. So the formula for copper carbonate is CuCO3. When we heat it, we form copper oxide, CuO, and the reason it's CuO is copper has a 2+ charge and an oxide ion has a 2- charge, so they're balanced, plus carbon dioxide. Now we need to make sure that this equation is balanced. We've got one copper on this side, one copper on this side, one carbon on this side, one carbon on this side, 3 oxygens on this side, 1, 2, 3 oxygens on this side. So it is already balanced, we don't need to do anything. Now, let's assume that we started off with 1 mole of copper carbonate. And we wanted to see how much copper oxide and how much carbon dioxide we produce if we had 1 mole. So the very first thing we need to do is we need to look at the relative formula mass for each of these. So I'm just going to give them to you because you've had lots of practice doing this. This is copper carbonate is 124 because I've got 1 copper at 64, 1 carbon at 12, and 3 oxygens at 16. You just have to trust me that that's right. Copper oxide is 80, and that's because I have 1 copper at 64 and 1 oxygen at 16. And then my carbon dioxide is 44. I have 1 carbon with a relative relative atomic mass of 12, and 2 oxygens with a relative formula mass of 16 each. So if you remember back from our last lesson, if I have 1 mole of something, the mass of that in grams is equal to the relative formula mass. So 1 mole, the mass of 1 mole is equal to the relative formula mass. Okay. If I was to heat 1.24 grams of copper carbonate, how much copper oxide do you think I would produce? Pause the video and have a go. Okay, so hopefully you got the following answers. If I had 1.24 grams, I can see that that's 1/10 of that, 1/100th of that. And so I'd have 0.8 grams here and 0.44 grams here. And this will always be the case. So if you're in the lab and I'd asked you to heat up 1.24 grams of copper carbonate, you would have ended up with 0.8 grams of copper oxide. And that will always be the case, as long as you did the experiment properly, because the ratio of copper carbonate to copper oxide to carbon dioxide will always be this, because these two numbers add up to 124 grams, because you have to have the same amount of products with the same amount of reactants form the same mass of products.